If you are currently leveling up your Django skills with this tutorial, just to let you know, this tutorial is part of a free YouTube playlist, Django Database Structural Testing, where we learn how to set up and utilize PyTest for database structural testing within Django projects. If you like this tutorial and playlist, then also check out our Django Database ORM Mastery course on Udemy. The link to the course and playlist should be found in the video description. Database testing comes in three main flavors, or there's three different types of tests that we can perform on our database, each of them testing different aspects of the database health. In this module of the course, we are focusing on structural testing, but as we move through the course, we will introduce the different testing types. In this tutorial, we do focus in on trying to answer the what is structural testing. So let's start off with the question, what is structural testing? Simply put, database structural testing validates the integrity of databases design. If we think about a general life cycle of a database, we start with the specification of some sort. We understand what type of data we want to store in the database. We go ahead, relational database, we might normalize that data, design our tables and the relationships within our database. And then we go ahead and we implement our design. In our case, that was Django models. So database structural testing validates the integrity of our database's design against what we have actually built in our database. So if we draw a line here between design and implementation, we're going to build a test or tests to make sure that our actual database design meets or matches what we're actually going to implement in the database. If we take a look at the database design, we can see that we have developed a database design which includes multiple tables. Inside of a table, we have fields. Fields have attributes and data types, and these are all the attributes that we need to ensure that are correctly defined when we actually build the database, in our case with Django models. So when building database structural tests, what we're going to test here is we're going to ensure that the tables, columns, relationships, and constraints are defined correctly in our case, our Django models, and then a bit later on, we'll actually check that this is the case within the database when we migrate the Django models to the database. So if we think of a simple example of a structural test, for example, in our design, we know that we have a product table, and in this product table, we have a field, for example. We could pick any, but we're just going to pick the name field. So that name field should be, if we look at our design, it should be unique, it should be not null. So let's just go for unique. So it should be a unique field. So we're going to build a test to make sure that we have implemented that correctly within, in this case, in our Django models. So we're going to build a test to make sure that, if just DM Django models, we're going to build a test to make sure that what we specified in our design actually matches what we have built and what we will be actually implemented in our database. What might be important to understand is that there are different approaches to building, constructing a database. So let's go for our design again. So we go ahead and we design our database. What we can do is we can just use SQL, structured query language, and we could actually build our database tables and fields, etc., directly in the database. So that is one way of actually building a database. And then we can use structural tests to test the design against the database that's actually been implemented in the database. Here in Django, it's slightly different, of course. We have our design, we implement Django models, DM, and of course, Django then migrates this to our database. We have an additional step here in Django, and then that goes into and creates the tables and fields in the database. So here in Django, there might be two phases of structural testing. We might want to first structure test the design against our Django models, and then we might want to actually test the design that's actually then implemented in the database, so the migration process. maybe, just maybe, that the migration process didn't work as specified. So we want to make sure that not only potentially our Django models are correct, but we want to make sure that Django migrates our models correctly to the database so that the database is created as per specification in our design. In this module of the course, we're going to just focus in on the first section. So we're going to be building structural tests to test our Django models against the design. And then a bit later on, we'll go ahead and build some tests to check the design against the migration, the actual tables and fields in the database. So our goal in this module is to build a range of structural tests to make sure that our database is developed to our specification. If we think about what's involved in our specification, our database specification or design, we have table and fields. So we're going to need to check for that they are correctly defined. Naming is correctly defined. We're going to verify attributes such as field lengths, null constraints, required fields, and think about the relationships between tables to make sure they're correctly defined, and any data types and lengths will also be checked. There are always strengths and weaknesses, benefits, drawbacks, advantages, disadvantages. So in terms of structural testing benefits, structural testing is going to help prevent issues that can arise from human error, from translating the design into, in our case, Django models. Just like in software development, testing is going to help ensure that changes to, in this case, the database schema doesn't break any existing functionality. Maybe your database will scale, grow, evolve over time. Those changes that you make to the database, we want to make sure that we don't break any existing functionality. Testing is going to help us ensure that that is the case. Overall, having structural testing in place is going to help maintain the data consistency and integrity across the database lifecycle. Sometimes it can be very difficult to see the value in testing, and there's always a case for not actually needing testing in some scenarios. So, for example, if the database is very small and simple with a straightforward schema and minimal relationships, the risk of structural issues might be lower, and therefore rigorous testing might not seem necessary. Testing can be sometimes considered quite expensive, particularly if you have limited resources or tight deadlines. It might necessitate you to prioritize other activities over testing. I think that in cases where structural testing might seem unnecessary, I think it's always important to acknowledge that these scenarios come with increased risks. Manual verification and reliance on a static schema without testing can lead to undetected issues, particularly as the application evolves. Therefore, even if structural testing is not initially implemented, it's always advisable to revisit this decision regularly and consider incorporating structural tests as the project grows in complexity and importance.